to finish worksheet 5 and 6, okay? That's the goal, is to finish 5 and 6. I'm not sure we'll get 6 done, but we're going to try it. Worksheet 5, what did we, first of all, let's revisit a couple concepts. This concept of convergent and divergent, do you remember how this went? Anything that is arithmetic, where you're constantly adding something or subtracting something, cannot be convergent, because it's going to either approach infinity or negative infinity, and that is not called, that's called divergent. Okay, convergent means it's approaching a single unique real number. So convergent can be geometric sequences. Okay. For example, if you're taking 1% of everything of the previous term all the time, you'd be down to nothing pretty fast, right? Unless you started with 12 billion, but even then 1% isn't much. Eventually, very quickly, you'd be down to next to nothing. All right, a convergent graph would also be approaching a single number. This is not convergent. This one is, as the term numbers increase, it gets closer and closer to 0. This one is jumping back and forth, so it's divergent. All right? Any questions about those? All right. The other thing we were working on towards the end of class was the sums and the summation notation. How far did we get? We talked about this? Okay. So using the summation, this symbol is called a sigma. It means to add up all the terms. This notation right here that I've written as an example means add up term number 1 through term number 7 of this sequence. This is the explicit formula for a sequence. The way you would do this by hand is you would put in a 1 and get out, what, 4? To a 3 on a good day, right? If you put in a 2, you'd get out a 5. If you put in a 3, you'd get out a 7. You would put all the way up to a 7, term 7, and then you would just add them all up. Okay? So I'm thinking, what, 5th grader could do that question, right? Okay? If they had to write it all out and add them all up, they could handle it. We're going to get into some messy ones. But this first example right here, we don't want to use a calculator for, because there's no formula given. Okay? So what's going on? We want the 7th partial sum. This is new vocabulary, but the 7th partial sum simply means the sum of the first 7 terms, okay? But anybody looking at this, it goes up what? Add 12, add 11, add 10. Nothing pretty, right? So if we added 12 and then 11 and then 10, what would the next one be? Add 9, which would be 20, and then add 8, which would be 28. Are we out to 7 terms yet? One more. Add 7 and we get to 35. But there was no nice formula for that. So the only way to do this one, but the easiest way anyway, is to write out the 7 terms and add them together. I don't know. Anybody get 63? So that's always an okay way to do a partial sum, is to write out all the terms and add them up. Okay. If it's already in summation notation like this one, or if we can write it in summation notation, then we can do it on our calculator. Now, on the calculator, if you have the newer operating system, it's super easy. When you're on the home screen, you go Alpha Window for the little F2 shortcut key there, and it's choice number 2. Okay? This is not what you get. Did you get something nicer? Okay. It's because I'm not in math print. Right. You get something that looks like this, and you can just type in all those little boxes. Whatever variable you want to use, equals, and this particular question over here says start with term 1. Up on top of the summation, it says you're going to end with term 5. And then in the parenthesis behind the summation symbol, it wants you to write the formula using the same variable that you already used underneath. Now, I just about could have done that faster by putting in a 1 through 5 and adding them up. Okay. If you just want to check yourself, that's fine. If it says add up the first 15 terms, for sure the calculator's going to be faster, right? But if it said to add up the first 3 terms, it's not even worth using the calculator, possibly. All right, if you have an older calculator, can I show you what you have to do? Everybody, I really would like everybody to watch this because there's some buttons here. This sum is under second stat and arrow to the right. You see choice 5 here says find the sum. Now when I push that, do you get just the word sum, everybody? Okay. Then if you go second stat again, an arrow to the right, now we want sequence, and this is where the two calculators are different, okay? If you have the upgraded operating system, when you push sequence, you get this screen that leads you through what to do. If you don't, you have to put commas in between. But you would write the expression 4n minus 3 or 4x minus 3, then comma, then the variable, comma, the starting term number, comma, the end term number. So it will look like this on your screen. Sum sequence 4n minus 3, comma n, comma 1, comma 5. And then the older calculator will still find the sum of 45. Okay? So just to help out those of you with an older calculator, I'm going to write it on worksheet 6. So it was second stat, an arrow to the right a couple times to find sum. And then it's second stat, arrow to the right once to find sequence. And then you write, let me write this in a better place here. It will look like this, sum, sequence, and you write the expression, the explicit expression, comma, the variable, comma, the starting term number, and then the ending term number. Right? So our example was sum sequence for, somebody tell me what it was. Comma n, comma 1, comma 5, maybe? Oh, whoops. Hello, go away. Okay, so that's what it would look like on the older calculator if you didn't have those little prompts. Any questions? Anybody got an older one and need help getting it to work? Oh, it's not that bad. At least you can do it on there still. So, all right, we're going to go back to here and do some more practice. Just kidding. Where's that coming from? All right, so let's try. Oh, this is another example, and I don't think there's one on a test or quiz. It might be on the homework where you approach infinity because this is a converging sequence. If you put in a 1, you get 7/10. If you put in a 2, you get 7/100, 7,000, 7/10,000. So if you add those up, it's 0.777, and you just keep adding another 7. So it would, as you get closer to infinity, it would approach 0.7 repeating, which is 7/9. Okay, so that's a sum with an infinity. Not quite sure. Did we do this one the other day? Can you find a way to do this one? This is how you would type it in if you had the older calculator. If you had the newer one, you can type it in just like this. Or you could put in a 1, in which case you'd get 2/4. If you put in a 2, you get 4/4. Put in a 3 and a 4. This reduces to 1/2, 1, 4, okay, 2 and 4, which is 7.5. So you could write it out and do it. Everybody figure out one way to do it, whichever you liked. Okay. Find the sixth partial sum of this. Could you use your summation symbol on your calculator for this? Yep. You gave you an explicit formula, so you would just do something like this. All right. Or write it out like this. Where am I getting the 6 again? The word was written out here, sixth partial sum, right? If I want to do it by hand, I can put in a 1, put in a 2, put in a 3. Actually, if I put in the first few, I might notice it's going up by 4. And I'm trying to find the first 6 added together. This is go ahead, Claire, what was your question? When it says a partial sum, it always wants you to start with the first term. Yes, yes. Good question. Guys, this is leading up to a concept that we will discuss tomorrow, but if you look right here, what do those two add up to? 26. What do these two add up to? And what do these two add up to? Okay. Anytime you're increasing, anytime it's an arithmetic sequence, okay, the first and last and so on will add up to the same thing, and that's going to develop a formula for us. Okay. This is 26 times 3, 78. Was that the answer to this? Okay. What's different about number 11? Yeah, it's based on the previous term. What's that called? Recursive. Very good. This is a recursive sequence. We could try to write it into an explicit format so we could use the summation notation if it was like really complicated, but it wants 4 terms. Can we just figure that out? Didn't they already give us the first term? -1. Then you plug that in, right? What's -2 times -1 divided by 5? +2/5, okay? Then you have to put that back in. What's -2 times 2/5 divided by 5? Well, that's -4/5 divided by 5 is 1/5 of that, so it's -4/25. Can you see where this is going? Not yet. If you plug that back in, -2 times -4/25 is 8. +8/25 divided by 5 is 1/25. And you're actually done because you only needed 4 terms and you had to add them up. Okay, so if you type that in your calculator and add it up, it'll give you an exact decimal or an exact fraction. They're both exact. How do I know the decimal is exact? because it only gave me 3 places, right? It stopped. So negative 0.696 or negative 87 over 125, either one are exact. Everybody okay? We're going to talk in a minute about you doing these on the y equals button and generating the terms in the table. Remember we did a little bit of that last week? So we could have used the table to come up with those 4 terms as well. All right, what's going on here? A couple more examples real quick. What's weird about this one? It has a squared, but what else is weird? Starts with the 3rd term, right? So we need to put in a 3, 4, 5, 6, 7, unless you have that summation symbol, or you could do sum sequence n squared minus 2, comma n, comma 3, comma 7. I'm going to put them in real fast. 9 minus 2 is 7, 16 minus 2 is 14, 25 minus 2 is 23, 36 minus 2 is 34, 49 minus 2 is 47. If I add those up, 54, 48, 23, 125. How did I do? Okay. This one, really easy to put in my calculator, right? It's an explicit form again. And I have to do 6 of them, so it might be more fun on the calculator. It is kind of weird it has an n minus 2 up here, but that's all right. If we put in a 1, we get 3 times 1/2 to the negative 1. Can you do that in your head? What do you get? 6, because this just flips over, right? If you put in a 2, you get 3 times 1, which is 3. 3 4s, 3 8s, and 3 16ths, I think. Because you're just multiplying by 1/2. But what'd you get on the calculator? 11.8125, is that what I heard? Which is what fraction? Anybody have a question? Because there's infinite numbers, right? This is at the end of worksheet 6. Everybody knows a couple ways they could do that question now? No? Do you need me to demonstrate multiple ways for you to do that question? You could just go alpha window to. Don't be asking me how to do this on the quiz, by the way. What? Standing on the quiz. Ah, I get it now. I was like, I totally am missing something here. Did someone get that ugly number, 35.705, blah, blah, blah? Okay, that's a painful one that I don't think the calculator is going to change back to a fraction for us. All right. Another way to do that would be to write out all 10 terms. Not sounding fun. All right. Last question on worksheet 5B. Yeah, thanks. It's 5B, right? All right, this is an application that says a pump removes 15% of the air from an inflated air mattress on each stroke of its piston. The air mattress originally contains 20 liters of air before the pump starts. Write the first 3 terms of the sequence representing the amount of air that remains in the mattress after each stroke. So term 1 means that it has been reduced once, right? the amount of air after one stroke. So if we want to call term 1, how would we calculate term 1? Okay, 15% of 20 is 3. Is that the first answer? It takes out 3 liters the first time. Yes, that's 15%. Is there an easier way to do that so we don't have to go back and subtract every time? 100% of the air minus 15% of the air leaves what? 85% remaining. Is everybody okay with that? So if we said 20 times 0.85, we get 17. Same answer as if we did 20 times 0.15 and then went back and subtracted from 20. But how do we find the next term? Do we subtract 3 again? Yes, 85% of the previous term. So 17 times 0.85 would be, are you helping me? One more time. Okay. And the third term, it only asks for the first 3, so we got this. So 14.45 times 0.85 gives me what? 2825. Thank you. All right, so there's the first 3 after. Now, we could have started with term 0 and said term 0 was 20 because nothing has happened yet. The reason we could have done that, we might have wanted to do that, was because then our explicit formula could have said take term 0 of 20 and multiply, I'm sorry, this would be the recursive form. I'm totally lying here. The previous term by 0.85. Or most of you would have said the first term is 17 and I'm going to take the previous term and multiply it by 0.85. Either one of those will work for the recursive, not explicit. Anybody have an idea for the explicit? It is geometric, okay? So at the bottom of your quiz, it would say this for geometric. So what would that look like for this particular question? Okay, that's what I heard. 17 times 0.85 to the n minus 1. Does anybody know how we could write that if we wanted to start with 20? You'd only need an n because the first term would be when you multiply by it one time. Okay? You could have written it this way as well. I will take either one though. It's not anything tricky. Okay, you could do either one. Is this sequence going to converge or diverge? We could practice putting it in our calculator, which is what we're going to do next anyway. And then we could look down the table of values and see. But if you're taking the air out of the thing, it's going to eventually get close to what? Okay, all it asks is does it converge or diverge, but it does converge to 0. All right, and you have a book assignment that's due tomorrow. Okay, but also due tomorrow is worksheet 6, so let's go to worksheet 6 and start reviewing some stuff and getting this done, okay? We'll see, we got 20 minutes, and I think we have 5 questions we need to do, is that right? Okay. I don't know if we'll get all 5 done. If we don't, we'll do it tomorrow, I promise, okay? Before the homework check gets turned in, we can do one together. This question, if you keep track of Hofbauer comments like this, is on the quiz, okay? Question just like this. It says you're depositing $30 each month in a credit union savings club account. The interest rate is 0.4% per month or 4.8% annually. The balance at the beginning of the nth month can be given by the following recursive function. Find the balance at the beginning of the 6th month. So what happens is you open the account with $30. Then on the 1st of the next month, you add $30 and you earn interest. So it's going to be 60 point something because it's plus change. 12 cents maybe, 11 cents, I don't know. Okay, now what we need to figure out is we're going to put this in our calculator. Guys, this is really just the do you know how to use your calculator question because it looks just like this on the quiz. These are what you type in, okay? N min is our minimum term number, which is 1. And remember, this means the value of that term. What is the value of term 1? 30. And then in the middle of there, we're going to put the equation, which is this, what they wrote right here. They wrote out for us. You're going to put 30 plus 1.004 u n minus 1. And remember, this u is second 7. So you need to be in sequence mode. Go to your y equals. It's term 1. If you arrow down twice, its value is 30. Now it always puts that number in some goofy little brackety things, but you don't ever have to type those. It'll just do it for you. And then here was 30 in the middle one where it says UN. It's 30 plus 1.004 U, which is second 7, parenthesis, n minus 1. And you could put a multiplication in there. You could put some parentheses in there. You do need parentheses around the n minus 1, if I could type. What does u n minus 1 mean? Yes, it means the previous term. That's just the way the calculator does it. It's not like function notation. It's supposed to be a subscript. Okay. Now if we go to the table, it says there is no term 0. There are no negative numbered terms, but term 1 is $30. Term 2 is 6012, which is what I got when I did it by hand. Okay, so how are we going to answer this question? We're just going to go to the 6th one and write it down. I need to show you something though, guys. If you go down to the 6th term and over to the right, it does give you the exact decimal. I don't want the exact decimal. I want rounded to the nearest penny. So that's the answer I'm looking for. But can I show you this real quick? If I had said I want term 100, when you get to term 100, either by scrolling or changing it, and it takes forever because it's basing it on the previous term, so it's got to do it. Look at this number. I don't know if you can see, but it says 2679.8. If I arrow to the right, it's actually 3, it said 36, I think I said 2. 3679 and 76 cents. They just have rounded it to 8 because of the number of spaces that fit in that column, okay? So I want the nearest penny, so make sure you go over onto it and make sure you round to the nearest penny. All right, do you think you can do that on a quiz? Okay, exact same question, different numbers. Can you look at this one and think about how to write this? N min is going to be what? 1. And what is our minimum term value? 50. And then how are we going to find the next value? It's exactly like the last one. So don't do anything too drastic. What did it say to do on the last question? You start by depositing $50 more, and then what? 1.006. Where did the 1 come from? All of your money stayed there plus 0.6%. Do you vaguely remember exponential growth or decay? It's 1 plus some rate or 1 minus some rate, yes? That's the 100% of the money stayed there plus 6%. And then you're multiplying by the previous term. So when we go to put it in our calculator, it will say times u parenthesis n minus 1. Okay. So get it typed in. Now, it wants to know the balance December 1st. Why is it just 12 and not 11 or 13 or something crazy? Okay, we called term 1 January, right? If it says if you start in January, so term 1 was January, so term 2 is the second month. So December would be term 12. Okay, I'm going to cheat because, you know, that's the way I roll. And here's the first 4 terms, boom, right there, right? I'm not writing them all out in those little blanks. Is everybody okay with what I'm talking about right there? And then it says, what is the term in December 12th? For that, I have to scroll down and find term 12. And December 1st. And when I scroll over, it does round to just 20 cents, so 6/20/20. Any questions? I will tell you on the quiz, it's like this. It tells you exactly what to type in, okay? Basically, the struggle of this question is simply, do you know how to use your calculator? All right. This question is a little bit more of a struggle because it wants us to write an equation that's different. A ball is dropped from a height of 90 feet and bounces back to 60% of its previous height. So what do we multiply by? Yep. It's not losing 60%, it's returning to 60%. With each successive bounce, write a sequence that shows the height of each successive bounce. Is 90 the first bounce? Okay. I heard it's a 0 term and I heard it's a starting bounce. It's the starting height. Those are both perfect answers, okay? If we wanted to say term 0 is 90, we could, or we could say term 1 is what? 54. But the actual terms need to start with 54 because that's the bounce. It says the height of the bounce, not the height of the drop. And how do we get every term after that? Right. So right here, you could either write u sub 1 equals 54 or u sub 0 equals 90. It won't matter. But then to get the next term, you multiply by 0.6. So then you go to your calculator. If I want to call it term 0 is 90. And then I go up here and say second 7 parenthesis n minus 1 close parenthesis times 0.6. Then if I look at my table, term 0 is 90, but term 1 is 54, and that's the first bounce. Okay? If I had changed that to a 1 up here and a 54 down here, everything stays exactly the same except now term 0 is also an error. So either way, you could call that term 0, or you could have said term 1 is 54. All right, and then you're going to write those down off the table, yes? Can anybody tell me what the fourth one was, just so I have one more on my little paper here? 664. And I'm not sure that's exact, but it doesn't matter. I'm good enough. Okay. Anybody know if we could write an explicit form for this? Is it, we only know how to write those, well, we actually know a lot of ways to write those. No, we know explicit, arithmetic or geometric, right? Is this either one of those? This will be at the bottom of your quiz. What do we want to do for this one? It is geometric, so we would say a sub n equals what? Or u sub n, it doesn't matter. I'm jumping back and forth. Just the name of the sequence. The first term, what was the first term? We got to put a number there. 54 times, what are we multiplying by? 0.6 or 0.60 to the n minus 1. Everybody okay with the explicit or not? Yes, nice. Does that make sense? Because term 1, you would multiply by 0.6 once. Term 2, you would multiply by 0.6 twice. Beautiful, Miranda. All right, use your calculator to generate more terms. So look at your calculator, scroll down. Is this converging or diverging? Again, it's a bouncing ball. So what happens? Yeah, it's going to get to 0. It's going to converge and approach 0. Okay. This question we used to have on a test because we used to do a lot of these kind of sequences where there's actually both something being added and something being multiplied. And really the only way I know to do this is on the calculator. It says Miss Potter had 4.5 gallons of chlorine in her pool. Okay, so she started with 4.5. At the beginning of each day, she adds 0.3 gallons, and during the day, 18% evaporates. Okay, so she's adding and some is evaporating. Are we going to multiply by 0.18? So all minus 18% leaves what? 82% remains. So we're actually going to multiply by what? 0.82. All right, but what happens first? She adds 0.3 to the previous term. Everybody okay with that part? First thing in the morning, she adds 0.3, and then what happens? Yes, so then we multiply by 0.82 to get the 18% evaporated. Now, do you want to start with term 0 or term 1 here? If we start with term 1, we're going to have to find term 1. We don't know term 1. Do we know term 0? How do I know that this is going to be called 0 and not 1? Find the amount of chlorine at the end of each day. Is this at the end of the first day? No. This is what she started with. If we want it, could we calculate the first day by hand just to make sure this works? We would do what? What's the first thing that happened when she got up that morning? It had 4.5 and she did what? added 0.3. So she was up to 4.8. And then by the end of the day, she was down to 3.936. Did anybody get that? Okay, because 82% remained. Okay, so let's go in the table or to the y equals. I'm going to call that term 0. So at the top, I'm going to put a 0. I'm going to scroll down twice and put 4.5. And then in between there, ugh, gonna need some extra parentheses, guys. I need to start with a parenthesis and then say u parenthesis n minus 1 close parenthesis plus 0.3 because my calculator normally wouldn't add first. Close a parenthesis times 0.82. Is the first term 3.9636.936? Okay. Anybody not getting it to work? All right, so here's the list of terms. Again, Hofbauer's too lazy to write them out. Is 4.5 day 1 or day 0? We already talked about that. It was day 0. 18% evaporating meant 82% remaining. Does she add or evaporate first? She adds first and then multiplies. So we used term 0 was 4.5. And we did parenthesis u parenthesis n minus 1 plus 0.3 close parenthesis and then times 0.82. Okay. End of day 7. I don't think that's on my little screen here yet. Day 7. 2.1478. Okay, guys. If she... Okay, what I need you to do is to realize that this eventually reaches equilibrium. It eventually approaches a constant value. Does anybody see what it's approaching? It's 1.3666. Okay? It eventually will approach 1.3666. If we want to make it approach exactly 1, what number do we have to play around with and change? And I only know how to do this by trial and error. Yeah, what she's adding. If you change what she's adding to 0.2, and then see what it approaches, it's 0.911. So what do we need to add? 0.25 or I think 2.2 is really close. Can we try 0.22? I'm going to insert another 2 here. No, I'm just kidding. I'm not. Okay. If she adds 0.22, is it gallons? Every day, it will approach 1.00, and that's pretty close for me, okay? We have one question left, and we'll try it tomorrow together before the homework check is due.